Thanks. Good morning again. My name is Joad Winter. I'm from Utrecht University. It's really a great pleasure to introduce now Peter Gardenfors, who doesn't need an introduction at all in a conference on spatial meanings. He's a professor at Lund University, as you all know, has done the amount of work he has done in this area is something that I could not describe, and I'm especially delighted because he's going to talk about conceptual spaces and semantics of prepositions, on which he has been working with a great colleague of mine, Joost Zwartstein, in Utrecht. So, Peter, the floor is yours.
Well, I will get to the prepositions, but before I do that, I'll introduce the more general framework I'm working in. And so my basic question is, why are there word classes? When you go to school, you learn the meaning of word classes by saying that a noun denounces objects, an adjective denounces properties, a verb is about actions and events, prepositions are about relations, and so on. When you go to philosophy, study logic, everything is bundled into predicates. These distinctions are just muddled over. And that's a problem, I think. And if you go to formal linguistics and study linguistics, the word classes are defined by syntactic criteria. They forget about it, the semantics. So my aim is to give a semantic analysis of why we have word classes. That's the aim, a cognitively based semantics for why we have word classes. So I'll get to the prepositions, my newest theory of prepositions, but I'll tell you a little bit about this project in general. And I've written about it in this book, The Geometry of Meaning. I'll give you a very brief summary of the second half of it. And I was very pleased to see that the cover is almost the same as this one. So anyway, that's the general plan. And my way of modeling the conceptual semantics is in terms of what I call conceptual spaces, and that's a previous book of mine. And the idea there is that we organize information in structured spaces. Space sizes are, for me, a fairly general notion. So in a sense, this is another meaning of spatial cognition. It's not ordinary visual space, but it's kind of mental spaces. And an interesting assumption I'm making here, or it's a fairly strong assumption, is that we can identify a number of dimensions. Like, I've given you some examples here, but there are lots of dimensions. And these dimensions, they have some kind of structure, and I give you a few examples of them. And many of them are linear, but not everything is a linear dimension. So they have a certain geometry. And they are sorted into domains. We have the three spatial dimensions that form one domain. I'll talk about the color space there. We also have three dimensions. Emotion space is very often defined in 2 dimensions. You can discuss that. Smell is defined in 4 or maybe 5 dimensions. We sort the information into domains, and each domain has its topological structure. And that's my second strong assumption here, is that we represent concepts as convex regions in these domains. And convexity, I'll get back to what that means, but it's nothing very difficult. So here's one example of a domain, the color domain. And this is a psychological space in psychophysics. It's been established that we sort colors by 3 dimensions. There is U, the circular dimension going from red, blue, green, yellow. There is the intensity going from gray and to more and more intense colors. And there is the brightness going from white to black. These 3 dimensions are not totally independent. As you get close to the white top there, you can make fewer discriminations, and as you get close to the black, you make fewer discriminations. So this space is based on similarity judgment. You have a number of subjects, you ask them how similar are the colors, then you'd use multidimensional scaling or something like that. You end up with a space that looks basically like this. This is an empirical finding. Human color perception is 3-dimensional. Some animals have 2-dimensional color space. Some animals have 4-dimensional color space. So this is an empirical thing. But this is more or less universal in humans, this kind of color perception. Okay, some people are colorblind, they have distortions in the space and so on. But basically, we have the same color perception system. And that shows up in language, and I'll tell you why in a second here. So the notion of a domain and the notion of convexity are the central points for me here. And that's what I will be using in my semantic analysis. So let's get into business here. I make a distinction between properties and objects. This is one way of sorting up the predicates. Properties and object categories. A property is something that lives on one domain only. So that's what I mean by a property. And a property is a convex region in one domain. An object category, or more generally a concept category, may involve several domains. So let's give an example of a property. So let's get back to the color space. So the property of being red is a region of the color space. I haven't done a very sophisticated drawing here. It should be three-dimensional region and so on. And the idea of convexity is that if anything in the region is called red and anything else in the region is called red, then anything in between is also called red. That's the meaning of convexity. You can have vague borders. That's no problem. I mean, you have vague memberships and so on. You can still have a level of membership, and you say that anything that passes, if 2 points pass the level of vagueness, then anything in between should also pass the level of vagueness. So vague borders is no problem for convexity here. Now, different languages carve up the color space in different ways. Some have few color terms, some have many color terms. But my prediction, which I made then 15 years ago, was that in natural languages, all color terminology, all color terms map onto convex regions. That was the prediction I made. I'll get back to that prediction. So then we get, okay, I should say now, let me save that. Object categories then are things that refer to entities that have several properties. So when I talk about a chair, it has a size, it has a shape, it has a color, it has a temperature, it has a weight. It has properties in many domains. And normally, when we talk about a dog, it has a size, it has a shape, it has a sound, it has a smell, it has a weight, and so on. And there are correlations between the things in the domains there. I mean, the sound of a dog is depending on its size. The barking is, you can tell the size of a dog from the pitch of its barking. I mean, there is a fairly strong correlation there. So object categories for me is information that contains information about several domains and connects information, brings out correlations between information and different. And my simple analysis here, I mean, I say this is a rule of thumb, that nouns refer to object categories. And I mean, I don't want to talk about abstract nouns, but we can look at how children learn words. And actually, this project of mine is to give some kind of explanation of how children can learn words so efficiently as they do. And my answer to that is they exploit these geometrical structures of the conceptual spaces. They use that. They use the convexity. They use the sorting into domains when they learn the meaning of new words. So this is my general take on it. Okay. Now, let's get into, I mean, I don't want to say very much about nouns here, but I want to say something about other word classes. So let's start with adjectives. So for adjectives, I have this thesis that an adjective denotes a property. It refers to a single domain, and it refers to a convex region of a single domain. That's a general semantic principle for the meaning of an adjective. So that means no adjective means green or orange, because that's a non-convex region. I mean, you can mean green, it can mean green or blue, because that would be a convex region of the color space, but not green or orange. There is no adjective that means long and hot, because that involves two domains. I'm not sure that this rule is 100% true. But it's okay if it's 90% true, because then it would still help kids pick out the meaning of an adjective. If they find a word marked as an adjective in their language, syntactically marked, then they know that it refers to some domain, and they have to pick out the right region of that domain. So, and for most simple adjectives, I think this principle works. Now let me get back to this convexity criterion for color words. When I made this prediction, I only had data from a few Western languages. Then Gerhard Jäger in Tübingen, he went through the word color survey, and there is data from 110 languages. Some of the languages only have 2 informaents and so on. And he used the Mansell color ships, and they don't cover all of the color spaces. But basically, he checked the data available, and he found that you could explain the 94% of the data could be explained by convex regions. And most of the rest is just statistical variation, because if you have 2 informaents, I mean, there will be errors or non-convexity. So basically, he confirmed my prediction that in all languages, all color terms refer to convex regions. So this is a kind of semantic universal of human languages. Now, I was very much encouraged by this result, so I'm going to put forward a similar thesis for the other word classes, and we still have to test it. I can't do that myself. So, that's adjectives. Now we'll get into verbs. And verbs are depending on events. Verbs describe events. So together with an Italian colleague, Massimo Vagli, and I've developed a very simple cognitive model of events. It involves I should point out. The focal thing is a patient. This is what something happens to. And there are 2 vectors. Now, vectors are then geometrical objects again. There is some action. I'm hitting somebody. I'm exerting a force on somebody. And then there is a change in the patient. The patient changes properties. He or she gets hurt, he or she moves, he or she bleeds, or whatever. And in general, there is an agent as well. So this is the simple model of an event. And the key factors are the force vector and the result vector. These are the geometrical properties, so to speak. And then there are some objects that act, or some entities. There is an agent, there is a patient, and we can fill in this model with further roles. I mean, in linguistics, people talk about thematic roles. And they talk about agent-patient, and there is a recipient. There could be counterforces and other things. So this is the skeleton. But we can fill in with further components if they are needed. But this is the basic skeleton. And in linguistics, people don't focus on the vectors, but that's what I want to do. So actually, the force vector is quite often a pattern. So I can paint a thing, I can move a thing, I can push a thing, I can do a lot of things. But and if I walk myself, I mean, I'm performing the action of walking, then I'm both the agent and the patient. I'm performing a force on myself. So, and it's a repetitive force pattern. Or if I'm waving, I'm also both the agent and the patient of this action. So they don't have to be distinct here. And I haven't talked very much about force space, but we can basically assume that this is a Newtonian force space. I mean, I don't want to get into any details here. We think of force patterns as forces in the Newtonian sense. And we can classify actions by the similarity of these force patterns. So running is more similar to walking than running is to crawling. We can talk about similarities between actions, just as we can talk about similarities of colors. So I could develop some kind of space of actions, but I haven't done the mathematics of it in detail. Then the result vector describes the changes of the properties of a patient. So if something is moving, it's changing its position in space. If I'm heating a soup, there is a change in the temperature. If something is growing, there is a change in weight or in size and so on. Sometimes there is no change. The result vector is nil. And then the event is a state. So a state is a special case of an event here. But note that the result vector then refers to different property spaces. Ordinary space or the other property spaces. So that's the model. And now the semantic thesis. Well, before I get to the verbs, I have a fairly bold statement here. I'm not sure I can defend this one. Why do we have sentences in languages? Why is a sentence a linguistic unit? Well, if you belong to the Chomskyan tradition, because noun phrase and verb phrase together make a sentence. But why? Why do we have this combination? Well, if you have this model of an event, you know that an event contains something that is happening. I mean, you can either take the force vector or the result vector, and it happens to something. So the minimal part of a sentence is an object is involved in some kind of vector change here. So and a construal, I mean, an event description is very complicated, a total event construct. But we have mental construals of events. And my hypothesis, or my starting assumption here, that the construal minimally contains one object and one vector. And the object then corresponds to the noun phrase and the vector then to the verb phrase. It's not a total explanation of why we have sentences, but I map the meaning of sentences on event descriptions. So the basic assumption here that a simple prototypical sentence describes an event or a state, if you like. That's a special case. That's why we have sentences, because events are very natural units cognitively. Okay, I'm not sure this thesis will hold water, but anyway, I throw it out. This is an important thing. The verbs also refer to single domains, and they refer to convex regions in single domains. I will make this thing over and over again. It's a verb root. I don't want to talk about verb inflections and so on. That is very, very complicated. And the domain is either the force domain or the result domain. So push is one verb. That refers to the force vector. So that's the force domain, or the domain of force patterns, to be more precise. And then you have a verb like move. It refers to changes in the spatial domain. Or a verb like heat refers to changes in the temporal domain. Or a verb like paint, a change in color domain, and so on. So this is an empirical claim here, that any verb root only refers to single domain. Fairly strong claim. I'm not sure I can defend it, but again, it's enough if I can do it for 90%. And they refer to convex regions. So, again, there are no verbs that mean walk and burn, because that would be multiple domains. There is no verb that means crawl or run, because that would be a non-convex region of the set of force patterns. Again, I don't know whether this prediction can be tested. There are some discussions in linguistics on some verbs that may have properties that don't fit with this. But still, as far as I know, I can get out of most of the counterexamples. So I guess that's what I want to say about verbs. We may get back to that in the discussions. I'm getting close to well, there's one thing I should say. In linguistics, some people make a distinction between manner verbs and result verbs. Manner verbs are about how you do something, and result verbs are about what happens, what is changed. And on my model, this distinction comes out automatically. Manner verbs refer to the force vector. The result verbs refer to the result vector. So given the event model, this distinction comes out automatically. Okay. Now, result vectors can also be expressed by prepositional phrases. They don't have to be expressed by verbs. They can be expressed by adjectives, adverbs, and all kinds of linguistic constructions. So walk is a manner verb, but then you describe the result of the walking in the prepositional phrase. And similarly here, the horses ran away from the fire. There are very often metaphorical uses of prepositions. So Franz came out of his depression. This is out of, then you are inside a mental state, emotional state here. And then coming out of means that you're leaving it. Now you're taking this emotional space, and you think of it as having regions. Depression is a particular region of emotional space. And then you improve and you get out of it. I mean, this is not ordinary space, but if you think of it as a spatial domain, in my terminology, this coming out of is very natural. It's a metaphorical mapping from this normal spatial meaning of out into this emotional meaning. And similarly, you can drink yourself into a stupor. I mean, this is moving outside for a space into something. So these are metaphorical uses of prepositions. And as we all know, prepositions are full of metaphorical uses. So now it's time to get to the prepositions. And now I get to the work that I've done together with Joost Swartz. And I have exactly the same kind of semantic thesis here for prepositions. Prepositions denote relations in a single domain. And I should have added, denote convex sets of relations in a single domain, because I will talk about that as well. It's the same kind of principle. Most content words, not nouns, but other content words, relate to single domains and are related to convex sets of single domains. This is a general claim I'm making here. Now I want to apply that to prepositions. Now, first of all, single domain. What is the domain of a preposition? Well, the tradition is that prepositions are about spatial relations. Well, many are, but not all. I mean, Barbara yesterday talked about force aspects of prepositions. And I want to make the claim that many prepositions are about the spatial domain, like above. Some are about the force domain. And this is a thesis we can discuss, because I would say that some prepositions like in, on, over, and under are basically force dimensional. They have a spatial component, but we will get to that. So I want to say that they basically depend on the force domain. And then some are temporal, like during or before and after. And some are even epistemic, despite, except, and so on. Don't ask me what the domain of epistemic is, because I mean that's very, very, very abstract. But this is my thesis. So I want to talk about the spatial and the force domain mainly. And then one thing that makes life difficult for me and others who study prepositions is that there are lots of metaphors. So it's difficult to separate what is the real base domain for the meaning of a metaphor. And I'll try to give you some reasons for why you can still identify the underlying base metaphor. So this is my general program for prepositions. Okay. Before I start, I need to say something mathematical here. And we are used to describing space in Euclidean coordinates. And most people are analyzing spatial terms in Euclidean space and so on. What Joost and I discovered is that if you use polar coordinates, you get a much more systematic description of the meaning of spatial prepositions. So, polar coordinates are like this. You have 3 coordinates. You have this is an origo, and you have the distance to the thing, and you have a horizontal angle, the phi here, and then the psi, and then you have a vertical angle, the phi here. So you can describe any point by using 3 coordinates. I mean, it's like space is still 3-dimensional, but this is how you describe the stars on the sky and so on. The important point of changing from Euclidean coordinates to polar coordinates is that you get a different notion of convexity. So the points between A and B here will be on the arc. Well, I mean, if you use Euclidean coordinates, the points between A and B will be this line. But if you have polar coordinates, keep the radius constant and vary the vertical or the horizontal angle, doesn't matter, you will get this line. That's the points between A and B. And actually, I mean, in general, the lines in here will be Archimedean spirals. That will be the general notion of a line in polar coordinates. So we get a different notion of betweenness. And this is a question I'm throwing at you as experts of spatial cognition. Do we really know that we define betweenness in terms, I mean, we perceive betweenness in terms of Euclidean coordinates? Or is there any evidence that we perceive betweenness in polar coordinates? I don't know. I mean, this is an empirical question, and very few have studied this question. So, but anyway, I mean, we are making the assumption that when it comes to prepositions, we're using polar coordinates, spatial prepositions. Now, I'm starting by talking about prepositions that are based on the spatial domain, and these are the most common ones. So given this notion of convexity, let's start with the prepositions. Let me start by the locational prepositions. So, inside and outside. A preposition is a relation between a landmark and a trajectory, something else. Let me make the simplifying assumption that the landmark is circular. So inside here is this region, and then this is a convex region well, both in Euclidean and polar coordinates, as a matter of fact. And outside is that region, the dots outside the landmark. And in polar coordinates, that's a convex region. This is very trivial, but still, I mean, inside and outside are spatial coordinates, spatial prepositions. Now take near and far. What is near is contextually dependent. I mean, if I'm talking about the near the sun, it's different from talking about near the projector. I mean, it's the distance is dependent here. But if you have some kind of this is the landmark, and there is then a distance that is contextually determined what is near. So this region would then be the near part. It's convex in polar coordinates. And that region would be the far region. Again, convex in polar coordinates. You have the directional front, back, left of, right of, and so on. And now we are looking for the landmark from above, yeah. And this is the prototypical front, this is the prototypical right of. There is an area here. I mean, we have vague borders here, it doesn't matter. The convexity still works, even if these borders are vague. And all these regions are convex. Actually, I should admit that we have a problem with the preposition beside, because that's too disjoint, and that's not a convex region. But we have maybe some ways of getting out the meaning of beside. Then we can have the vertical prepositions above and below. Now we get into this coordinate. And again, I mean, this is the prototypical above, this is the prototypical below. There is some vagueness on where the above ends or where the below ends. But still, they will be convex regions. Between is a bit different because now you have two landmarks. But still, I mean, you get a region that is like that, and a little bit depending on how you define this complication with the two landmarks. But basically, you get. I mean, this line is the prototypical between, and then you get this area. So, well, it's a bit of a technical complication here, but basically it works. That's the locational preposition. Now we get to the directional prepositions. So there are goal prepositions, into, onto, and so on, source prepositions, from, out, and route prepositions. We handle them, instead of having, the locational prepositions are identified by sets of points, or regions of points. Now, instead, the directional prepositions are identified in terms of sets of paths. So they all involve paths. So let me take one example, and we can define convexity of path here. So let me just take into. Well, let me say something about most of these can be given qualitative definitions. So out of means that he got out of his depression. Was the example I used earlier. That the initial state of the path is inside the trajectory. The end state of the path is outside the trajectory. We're using the preposition inside and outside, I mean the definitions of that. And it doesn't really matter how the path looks like, as long as the initial state is inside and the terminal state is outside. This path describes the getting out of something. And similarly for all of the other prepositions here. Well, over shouldn't really be on this list because there are forced uses of over, but anyway. Yeah, so let me do into. I claim that I form a convex set. So this is one path going into. Again, the starting of the path is outside, the end point is inside. That's the qualitative criteria for the meaning of into. And here is another path, outside and inside. And any path in between here, I mean, now draw a path that is in between, will also be an example of going into. I mean, the end point, you have to define this. And I mean, it can be done mathematically. This is our definition of betweenness and path. And basically, I mean, you have to distinguish between the sizes of the angles. But basically, you take the betweenness for this is x should be the radius, and this is the phi should be one of the angles. I mean, it's basically the standard definition of betweenness from linear algebra, but we apply them on polar coordinates instead. And as far as we can judge, all the directional prepositions will correspond to convex sets of paths. So that's the next analysis. Okay, that's the directional prepositions. Now let's get to another domain. And now I want to talk about prepositions that depend on forces. And this is an old picture from Annette Herskowitz, I think, or a modification of it. She noticed that we say that this pear is in the bowl. There are some apples and there is this pear. But the spatial location of the pear is not determining here. Because if we have this picture, the location of the pear in relation to the bowl is exactly the same. But we wouldn't say that the pear is in the bowl. And my analysis of this is that in requires some kind of force relation. I mean, the reason why the pear is in the bowl is there's some kind of support from the apples here, but there is no support here. And what this support means, support can be analyzed in terms of forces. But a way of testing this is that if you move the bowl, the pear will move. That's a way of identifying the force thing. If you move the bowl here, the pear won't move. So it's not in. So inside has something to do with the container exerting some kind of force relation with the trajectory. So if the container moves, then for the trajectory to be in the container, it should also move. It's a kind of test of the force relation. So let me elaborate a bit on this test. Two pictures of ducks in the tubes. Here, I think, I mean, we should ask native English speakers here. The duck is in the tube. But what do you say about that one? There, I would say that, I haven't tested it, but my prediction is that most people would say it's inside the tube. And again, if you move the tube here, the duck will go along. But if you move the tube here, there will be some leeway before it touches. So it's not, well, you could say it's in the tube. By the way, there is, of course, an ambiguity. It could be inside the tube on this side, but that's another fact. But basically, there is no direct impact of the tube on the duck here. So it's not a good example of being in the tube. Then, of course, there are many spatial uses of in. But I would analyze them as metaphorical uses of the force relation. A tricky relation. But anyway, that's in. Let's see. Now we have on. Here is the balloon has come up and is sitting. I don't know. I can't use a preposition here. What is the relation between the balloon and the lamp? Well, if you take the ordinary definition of on, something being vertically above and in contact with an object, the lamp would be on the balloon. But what do people in English say about this? I think you would hesitate, at least, to say that the lamp is on the balloon. There is some kind of odd relation. You don't hesitate. Okay. Yeah, you agree with me. Thank you. Good. Okay. I'm sorry. Underneath. Yeah. Sure. But that's then we have a different relation. We can take another clear example. The fly is on the ceiling. This is English expression. Actually, in Swedish and some other language, we say that the fly is in the ceiling. So there are lots of linguistic variations here. Why is the fly on the ceiling? I mean, it's under it, and it's in contact, but it's not vertically above. Well, the reason it's on is there's some kind of force between the feet of the fly and the ceiling. So this is, for me, one reason for, the on becomes a kind of landmark. I'm sorry, the ceiling becomes the landmark. And then we take some kind of mental rotation. I mean, the landmark is, and then there is some kind of vertical relation there is contact between the trajectory and the landmark, and that's depending on forces. I have developed what I call a rotation test for the primacy of the force domain. If you have a relation between a trajectory and a landmark that is invariant under rotations, then it is a force relation, not a spatial relation. So if you have something stuck if the fly sticks to a book and you turn the book around, the fly is on the book no matter how you turn the book. So the spatial direction is not relevant here for the meaning of on. That's my point. And that's my test for saying that the force domain is the primary one. I'll apply that to some other cases here. So let's do over. Again, normally over means vertically above. On the vertical dimension. And there are lots of meanings of over. But if we take this example of the board over the hole in the ceiling, there has been a hole, you have put up a board. But there is some kind of force relation. You have nailed the board to the ceiling. And that force relation is what constitutes over. The difference between over and on here, I mean, you could say that the board is on the hole, but over means has a covering meaning here. That makes it a bit different from the on relation. Or we can take, this is an example I like. You don't stand below a shower, you stand under it, because there is some kind of force relation between the water above you and water coming down. And another good example is underwear. This is, I mean, under means under in relation to your other clothes here. And no matter how you change your relation, if you lie down, if you stand up, if you stand on your hands, your underwear will still be under your own clothes, the other clothes. So that's again some kind of force relation. It passes the rotation test. Here is an experiment from Coventry and some other people. They showed the subjects different pictures of the man carrying the umbrella, and then they asked, when is the man carrying the umbrella over the head? And here it's about 100%, of course. Here it's less, but it's more than zero, and here it's very few people saying that the umbrella is over the head. But if you introduce the context of a rain coming from a slanted direction, many more people will say that this is over the head, because now there is the force direction, the force of the rain, makes this being over in relation to the rain. And some people would even say that this is over the head in relation to the rain. So this, introducing an element that brings in a force, an additional force factor in the situation, will change the meaning of over here. And that's another indication that over has this force component. In contrast to above, is a purely spatial preposition. Okay, here is the temporal preposition after and before, and here's my rotation test. Behind and front, that's spatial preposition, as I said. And if I'm standing in the queue, and I can say that she's behind me in the queue, but if I turn around, she would be in front of me. But I wouldn't say if she's after me in the queue, but if I turn around, she will be before me. No, because the before and after has to do with the temporal relation of the queue. I mean, the one at the front of the queue will be treated first at the bank or whatever you're queuing for, and the one after will be treated later. So turning around, this spatial rotation, doesn't change the temporal relation of the before and after. So this is, I apply this rotational test to the temporal dimension here. And it works to show that before and after are temporal prepositions. Historically, they were spatial, but they've changed into being purely temporal domains. Temporal prepositions. I haven't talked about the convexity of force prepositions. And the problem is that this is difficult, because what is convex will depend on lots of peculiarities of the landmark and the force vectors and so on. It's very difficult to give a general analysis of the force vectors involved in different situations. I can do it for some special cases, like in a container, then things will work nicely. But do it in general for these force vectors is very tricky, because there are no general patterns, or there are very few general patterns of force vectors involved here. So I still believe that the convexity works here, but you have to analyze each single case depending on what are the force patterns involved. So I can't give you the nice analysis I gave for the spatial prepositions. Temporally it works fine. The temporal prepositions are all convex. That's no problem, because temporal is only one dimension, and there it works out nicely. So that's basically it. That's my story about the prepositions. But if I summarize, I've given you some talk about nouns, not very much. I analyzed adjectives in terms of properties, regions of domains. I analyzed prepositions in terms of spatial and force and temporal relations. I've analyzed verbs in terms of force and result vectors. I haven't talked about adverbs. Adverbs are very complicated. I've looked a little bit at adverbs modifying verbs, and they work like adjectives modifying nouns. So I can actually give some evidence that there is convexity and things like that also for some of the adverbs, not everything. I said something about the meaning of an event, sentences as meaning events. But basically for these four main word classes, content word classes, adjectives, prepositions, verbs, and adverbs, I have a single semantic principle. They refer to a single domain, and there is some kind of way of describing these domains that they come out as convex regions of the domain. That's a fairly general semantic principle. But as I said, the reason for, the cognitive reason for why we have this is that this will help children in learning language. Once they can detect that something is a verb, they know it's either a result or a manner, and they have to figure out what it is. Or if they know it's a preposition, they have to find out what is the relation and so on. But that will be cognitive constraints that will help them in identifying the meaning of a new word. And so that will be part of the explanation of why children can learn new words, learn the meaning of new words so quickly as they do. Thank you very much.
Thank you. We have quite a lot of time for questions.
Thank you very much for your very interesting presentation. There is one observation about verbs in terms of force, because there are quite a lot of verbs which are traditionally in linguistics analyzed as lacking of force at all. For example, verbs like love, hate, and think. And how could you analyze that? Then maybe a second question. For example, there are some cases when the interpretation of preposition isn't connected with force, but with other factors. For example, in Russian, you don't say that English is sitting behind the adverb. It's said that behind. No matter its derivatives. The main thing is that it is neither the most important part of the instrument.
Okay, yeah. Thank you for the second example. That's very nice. As regards love and hate and so on, I mean, I talked about forces as being Newtonian forces, but of course we have metaphorical uses of forces, and I'm not sure that our normal cognitive notion of force is really just a Newtonian. But of course we talk about human relations in terms of forces. I mean, this is, if you have read Lakoff and Johnson's metaphors we live by, I mean, it's a very universal term that we talk about attraction in terms of forces, and we talk about mental forces in general. I don't know to what extent we should describe it as metaphorical, or whether this notion of force is really something basic to humans. But still, there are very large similarities with some kind of force relation, even for these mental verbs. And you can also use it in some kind of epistemic use, not just emotional. If I'm persuading somebody, I'm exerting some kind of mental force for somebody to accept this statement. I mean, we have these epistemic verbs that involve some kind of forces as well. So thank you.
That was very interesting. I have two questions for you, one a comment and the other question. The first is, I completely agree with you about the force dynamic meanings, and that they're so hard to capture because they do depend entirely on the interactions, the mechanical interactions between the specific objects that are in the relationship. And one friendly piece of evidence that we've been doing a cross-linguistic study of different kinds of uses that would, in English, be ins or ons. And so they correspond to either the canonical ones, like a bottle on a table or a ball in a bowl, and very non-canonical ones, so things like a crack in a table, for example. And what we find is that for the canonical ones, you get a lot of uses of the force dynamic terms in or on with be. So the X is in or the X is on Y.
Yeah, yeah.
But for the other ones, what we see is diminished uses of the in, but more importantly, greatly increased uses of other verbs, that is lexical verbs. So it's as if when you get a complex force dynamics, the bulk of the burden is on the verb to describe what the mechanical interaction is. So, you know, something like, you know, someone put a crack in a table. So that there's a, you know, you don't have anymore there, you know, a crack is in the table really sounds weird. You have to use the existential, there's a crack in a table.
No, you showed this yesterday.
So, so there's a difference, you know, one diagnostic of whether or not the force dynamic relationship is canonical or not is the extent to which you get other verbs intervening and sort of taking on the burden. So that's one sort of just friendly piece of evidence. The other is more a question, and that was, I found it really interesting, your proposal that the spatial terms are based on polar coordinates and not Cartesian ones. But I couldn't myself think of any critical examples that would test whether or not it really is polar instead of Euclidean or instead of Cartesian, and I'm wondering if you have any critical examples that would definitely show that it's one versus the other.
Well, thank you very much. I mean, the first friendly advice. I mean, I listened to your lecture yesterday, and I haven't done any cross-linguistic studies. I mean, I'm not really a linguist, and I relied on Joost's knowledge of different languages and so on. But of course, there are lots of variations between languages. I mean, in and on. I gave you this example that English says the fly is on the ceiling, Swedish says in. You have the converse. In Germanic language, you say the stars in the sky. Germanic language, no. Yes, the Germanic language says stars on the sky. For some reason. So there is no obvious pattern in this. And of course, Melissa Baumann and others have done these experiments where you show a number of situations, and you can map them. You can make some kind of space of the different kinds of situations. And you showed one of these maps yesterday. And of course, different languages will carve up these spaces in different ways. Some will call them in, and some will call them on, and so on. And so there is always an overlap I mean, there is a region, there is prototypical in and there is prototypical on, and then there are regions in between, and you can draw the lines in different ways in different languages. This is similar to the situation with color words. I mean, there is no universal solution for whether you call a particular relation an in relation or an on relation. So lots of complicating factors, and each language will have to be studied on its own in order to determine what are the boundaries of the meanings here. So, I mean, the cross-linguistic elements I basically left out of my studies so far. Then, your question about polar versus Euclidean betweenness. I looked a bit for evidence, and everybody seems to take for granted that everything is Euclidean, that betweenness is really Euclidean. I have found no study directly relating to this. There was one study of macaque monkeys where they found that some of the neurons respond for polar betweenness and some of the neurons respond for Euclidean betweenness. That's about what I found. So basically, this is an unexplored area, and we should do experiments on how people perceive betweenness. I'm sorry, I can't hear.
Between would be a good case for you to distinguish whether or not, yeah. So if you think about a line that's obliquely oriented, and you have endpoints, and then you have something in between them, it's actually sort of odd to say, that A is between, or B is between B and C, unless you're talking about literally the line and the ordering on the line. Yeah.
I have a very simple example. You go out in an open soccer field, you put two cones, some angle, 60 degrees or whatever, and then you put another cone in somewhere in between these, in between in some time, and then you ask people to say what is the most typical betweenness, or you make distinctions of similarity of betweenness and so on. You could very easily find out whether the polar or the Euclidean notion of betweenness is dominant. Nobody seems to have done this experiment. And of course, it will be dependent on perspective. It's not sure that, it might be that at the close distance there is some notion of betweenness at another distance. I have no idea. It could be there's a difference between vertical and horizontal. But at least we should investigate how this works.
This is about adjectives, not prepositions, but what do you do with what we could call relational adjectives like edible, or where it could have been said as a verb, right? Someone could eat it, but you say it as an adjective. Do you want to treat those as properties or as...
Yesterday we talked at dinner about relational categories, and I didn't make any remarks about them here. I mean, if you have this event frame that I'm presenting here, you can have a verb, like, I mean, in your case, I mean, you've written about these relational categories, like steal. And then in relation to steal, you have the patient and the agent. And in steal, the patient will be called a thief. I mean, we have a certain lexical term for that, and the agent, the agent will be called a thief, and the patient will be called a victim, or whatever it is. In English, you have this general method of putting the ER. I mean, climb would be climber, and then you have the double E. Well, climb B, there is nothing that you're climbing on. But I mean, you know what, employer, and employee. I mean, you have this semi-generative mechanism for creating the relational nouns out of a verb. Edible comes from eat. I haven't thought about adjectives as being relational, but given your example, I should. So it's somehow, it's a relational adjective, and it doesn't fit really into my analysis. But now you give me the idea of relational adjectives, so I should look closer at them. But they are not, I mean, I don't want to say that they're not basic, but if you look at the adjectives that children learn first, and I've done that to some extent from the child list database, they all fit into this character. Lots of them are dimensional. I mean, tall and short and so on. I mean, these are the most basic ones. I would guess that edible comes pretty late in the acquisition data, which means that they're more, it's an indication they're more abstract than the basic dimensional one. But that's just a guess. Yeah. They come later, yes, okay. So I should think more about relational adjectives.
Peter, thank you. I want to return to these polar coordinates, and I think there is evidence. So, you know, I've been looking at the work by O'Keefe, you know, and O'Keefe. So, you know, it's from cognition. So the idea is that, you know, there's a notion of goodness of fit. Right? You don't just say, well, this is in front of me, and then, you know, you sort of vary it, and then you say, no, stop. Now it's out. Rather, you know, all judgments are, even by individuals, they're graded. So if you take that into account and you draw a map of goodness of fit, then there's a variation, you know, of the distance according to the angle. So it's clearly, you know, a polar coordinate thing. So, you know, with in front, for example, the more direct it is, the farther out you can go. You know, as you move, you know, increase the angle, you know, it has to be closer to you. Yeah, so that's kind of evidence you might be looking for.
Thank you. What do you do with concepts that we have, such as inline? So, which combines, for example, different regions with each other, and I don't think that they're connected either by polar or geometric or Euclidean coordinates. So we run these experiments, and sometimes we find that some people have 4, for example, directions, and others just have 3. They differentiate, for example, left and right, but then have 1 for inline, or they have a concept called next to, and that can be either this side or that side. So, and those concepts would create regions that are not connected in that space. Is that sorry?
No, I don't know how to answer your question, but your remark made me think of one thing I forgot to emphasize, that in Euclidean coordinates, they are invariant of rotation and translation. Polar coordinates are invariant of rotation, but not of translation. They are dependent on origo. So you have to have the origo fixed in order to have these things working. And I mean, if you're talking about egocentric coordinates, you are yourself the origo. If you're talking, when I gave the presentations of the different meanings, I took the landmark to be the origo. And if you take between, that's a problem because you don't know what is, I mean, I had my preposition between, then you don't know what is the origo. And if you talk about in line, 3 points being in line, you don't know what is the origo. So I don't know how polar coordinates would apply there. But you have to decide that maybe one of the points is the origo, like you have to do, and then you can talk about the radius. I mean, the radius would be a straight line, and you would still have a nice notion, maybe. But I mean, this is a complication by using polar coordinates, that they are not invariants under translation. So I don't really know how to handle in line here. That means, I mean, having in line, you have to take this allocentric view of relations. And while my analysis is dependent on some kind of, not egocentric, but landmark-centered views of relations. So maybe that's another dimension to add to prepositions, whether we use the landmark-centered or an allocentric analysis of things. Make things more complicated. Did you? I mean, you haven't asked anything, so. Yeah, good. I like this.
We know that different species behave differently in space. So we see different representation for space in rats, who basically behave in 2D. But in the flying bats, we also are able to record from their place cells, and we see three-dimensional, beautiful firing fields, which are actually circular. So I was wondering whether for certain human activities, like the jet fighter pilots, who need to reference their position or whatever in 3D coordinates, so they are not, they simply can't, and they need to be very fast. I mean, not only describing before or in front of, to the left, but also the vertical. So did they evolve some specific classification of directions or positions in the 3D space?
No idea, but I must ask you a question. When you say that the bats, they have three-dimensional representation, you said they represent it in a certain fashion.
In a spheric fashion.
Spheric.
Yeah.
So what is the meaning of it spheric? I mean, what is the meaning that they represent as spheric? The question I'm asking is, do they use polar coordinates?
Oh. I don't know. Well, maybe I'll give the description of the representations in my talk a little bit. But you know, the firing fields, what we call the responsive zones of place cells, are kind of, let's say, circular in a rat. Okay.
Okay, I think it's time to thank the speaker again. The next speaker is Markus Kracht from Bielefeld University. Markus has been working for years on mathematical linguistics and computational linguistics, and he's a professor in those areas at Bielefeld. He has done a lot of work also on locatives and prepositions in general, and the floor is yours.